In 2017, Node.js 7.6 shipped with full support for async/await, and it changed how people write asynchronous JavaScript more dramatically than any feature since promises themselves. The syntax is so clean that new developers sometimes think it's a fundamentally new mechanism, something other than promises. It's not. Async/await is syntactic sugar, a more readable way to write the same promise-based code you were already writing. Understanding this is critical for debugging. Every async function, under the hood, returns a promise. The async keyword before a function declaration doesn't change what the function is, it changes what it returns. A regular function that returns 42 returns the number 42. An async function that returns 42 returns a promise that resolves to 42. Always. Even if you don't explicitly return a promise inside the function. The await keyword pauses execution of the async function until the awaited promise settles. It then unwraps the result. If the promise fulfilled, await returns the fulfilled value. If the promise rejected, await throws the rejection reason as an exception. This is the key insight: await converts promise resolution into a value, and promise rejection into a throw. That means your try/catch blocks, which have handled synchronous exceptions for decades, now also handle asynchronous failures. No more .catch chains. No more nested error handling. One try/catch can cover an entire async operation sequence. And the sequential control flow looks exactly like synchronous code. You write await read file, then await parse content, then await fetch URL, and they execute in order, each one waiting for the previous to complete, but without blocking the event loop. Here is a subtle trap that has confused experienced JavaScript developers, and the book addresses it directly. Inside an async function, what's the difference between return some promise and return await some promise? Most of the time, they produce the same observable result. But inside a try/catch block, the difference is significant and has caused real bugs. Consider this: you have an async function that calls another async function inside a try/catch. If that inner function rejects, you want your catch block to handle it. If you write return some async function, you're returning the promise without awaiting it. The async function resolves immediately with that promise as its result. It exits the try/catch block. If the inner promise rejects later, the rejection is not inside your catch block anymore. Your catch block never runs. If you write return await some async function, you're staying inside the async function and inside the try/catch until the inner promise settles. If the inner promise rejects, you're still inside the try/catch when it does, so the catch block runs as expected. Outside of try/catch, this distinction doesn't matter, the final result is the same either way. But inside try/catch, return versus return await is the difference between catching an error and not catching it. The book's recommendation is clear: inside try/catch blocks, always use return await. The performance difference is negligible, one extra microtask tick, and the correctness guarantee is worth it. Outside try/catch, returning a promise directly avoids an unnecessary await cycle and is perfectly fine. Here's an anti-pattern so common that it deserves its own slide, and the book calls it out explicitly. It looks correct. It's syntactically valid. It doesn't throw any errors. But it silently breaks sequential execution, and the bugs it produces are maddening to debug. The anti-pattern is using async callbacks with array.forEach. You have a list of URLs to process sequentially. You try to write urls.forEach, async URL equals, await process URL, URL. This looks like it should wait for each URL to be processed before moving to the next. It does not. Here's why. forEach calls your callback function for each element. Your callback is async, so forEach is calling an async function for each element. But forEach doesn't await the return value of those callbacks. It doesn't know they're async. It calls each one immediately, one after another, without waiting. From forEach's perspective, it's called synchronous functions and they've all returned. It doesn't notice they returned promises. The result: all URLs start processing simultaneously, in parallel, not sequentially. This is the exact opposite of what you intended. The fix is to use a for of loop instead. A for of loop is a JavaScript statement, not a function call. It understands await. When you write for const URL of urls, await process URL, URL, the loop genuinely waits for each await before proceeding to the next iteration. Sequential execution works correctly. This same problem applies to array.map, array.filter, array.reduce, and every other array method. None of them await async callbacks. If you need sequential async execution over an array, use for of. If you need parallel execution, use promise.all with .map. Async/await makes sequential code beautiful, but it also composes naturally with the parallel patterns from the promise chapter. Parallel execution with async/await means passing an array of promises to promise.all, just as before. The await keyword handles the rest. You write const results equals await promise.all, urls.map, URL equals fetch URL, URL. This starts all fetches simultaneously and waits for all of them. The results array preserves the order of the input, regardless of which promises result first. If anyone rejects, the whole thing rejects. This is clean, readable, and correct. For limited parallelism, the task queue pattern from the previous chapter applies directly. The async/await version of task queue makes the queue processing logic even clearer. The queue's processing function is async, it awaits each task, and it automatically starts the next one when a slot becomes available. The book implements this cleanly, and it's worth studying as an example of how async/await clarifies complex control flow. One performance note the book highlights: if you have two async operations that are independent of each other, don't await them sequentially just because it's easy to write. The pattern const A equals await first op, const B equals await second op, takes the sum of both operations' time. The pattern const A, B equals await promise.all, first op, second op, takes only the time of the slower one. When operations are independent, parallel execution with promise.all is always preferable. Async/await makes it easy to write accidentally sequential code for operations that could be parallel. Stay alert to the difference and your applications will be measurably faster.